Tatiana. Hello, everybody. Thank you for staying. Yes, I'm involved with JasperSoft for many years. Nowadays, I'm responsible for the development team that takes care of these products that we're going to see today. So mostly involved with reporting. I'll give you like 3-4 minutes to go through this slide in detail, and at the end there'll be a quiz to see if you assimilated this information. I'm just kidding. Well, our legal team would be curious to see the results. Anyway, I had to see that slide go. It was my best slide for today. JasperSoft. I would like to see how many of you have heard of JasperSoft or maybe know what we're doing, what products we have. Oh, not too many. Good. That's good. It's like it shows we have room to grow, right? We at least have this room to grow in. All right. Well, JasperSoft has been in the business intelligence industry for many years. We started with reporting, mostly. We initially had this Java library that I'm going to present briefly. And then we created products around it that tapped into data analysis and analytics in general. So we have a decent product suite that covers business intelligence use case scenarios. And today we're going to focus only on a couple of our products that, are offering scalability and, deal with big data and, the interesting topics of this conference, let's say. So we'll start by talking a bit about the origins of JasperSoft with the JasperReports library open source product. Then we're going to see its evolution from a Java library towards a REST API, to open up to other platforms and technologies. We're going to talk about interactivity and embeddability of our reports and visualizations. And we're going to see how these products cope with, peak demands and how they scale up to, deliver when needed. And we're going to review some of our customer cases related to use of big data technologies. JasperReports library. Well, free Java reporting library. This is the project that it had that's at the origin of our products. It's a project I started many years ago. It's a reporting engine that can use any kind of data, right? So I used to say we can produce any document out of any kind of data. And when I say it's data source agnostic, it means we can leverage data, of course, from relational databases, from XML files, JSON files, CSV, Excel. We can use data coming through REST calls in JSON or XML format. So anything you can throw at it, we can take it. If there is an exotic data source that you might have, it would be easy to write a data source implementation and adapt that data to our engine. Basically, what we need is tabular data, right? So no matter what the format your data is in, we need it tabular, like made of virtual rows and columns, and we iterate through that and process that into our engine. We produce this documents and visualization based on report templates that can be, of course, simple, but can also be very complex by use of sub-reports and nested layouts and various techniques. We can produce very complex documents. When I say complex document, I usually refer to an invoice. If you look at the power bill, an energy bill. It has a complex layout with many little tables and iterations and all sorts of contents, barcodes, images. We can do that. How are we doing that? Well, we have report design applications. We're not going to review them today, but there's this JasperSoft Studio, a visual designer for our templates, which helps create this pixel-perfect documents where you control fonts, alignment, styling, everything that you need to produce that, pixel-perfect document. We can export these documents to any format. Our reference document format is PDF. When we say pixel perfect, we usually mean PDF. I mean, PDF is, was for printing, for paper mostly. But then we supported basically all popular report formats, including Word, HTML, of course, Excel, PowerPoint, OpenOffice formats. And then when in special scenarios, folks need to produce or extract data, use our technology for extracting data, and we're able to output to CSV and data-oriented formats as well. I would say that across all these formats, we'll try to keep the pixel perfectness. I mean, it's one of our main objectives, and it's our strength, I would say. In terms of document size, only the sky is the limit, I would say. How we cope with very large documents, I mean, we sometimes hear about customers saying, hey, I have a document, PDF, it has 10,000 pages. My first reaction is, who reads that? I mean, but people do it. Maybe it's for archiving purposes, and the way we deal with big documents is that we use a so-called virtualizer. Basically, when we create documents page by page, because the PDF, for example, is page-oriented, we do not keep that document in memory all the time. We only keep 300 pages, the ones that we work with at any given moment, and the others are saved on temporary files on disk. We call that a virtualization process that helps us optimize memory consumption. So report size is not an issue for us. If sometimes text fields, images, charts, and the usual type of content is not enough, and you probably need a special visualization like a map, usually interactive map, or maybe some visualization technology that draws gauges, or I don't know, something that it's not in our palette of elements. We can implement what we call custom components. So we have this system in which we can plug custom content into documents. And we have a gallery of such custom components that can be used, or used as an example to create your own. Internationalization, the last item there. Usually internationalization is an afterthought, at least in my case. Every time I start a project, it's later on that I say, oh, it needs to be internationalized. With Jasper products, internationalization is available upfront. So everything can be translated using a system of bundles, and we even have helper tools to translate the content that you need. All right. All this that I presented was about, the reporting engine, which again started as a Java library. It was created at a time where there were not that many products of this type available for the Java platform. But then later on, the industry and technology moved more and more towards web. So we had to adapt or keep the pace with the evolution of the technology. I mean, at some point, people were no longer creating Swing applications or desktop application or RCP application based on Eclipse or whatever. People were creating web applications, and they wanted to display the reports in HTML format. So our focus shifted at some point from PDF towards HTML and interactivity. Now that you're in a web application and you see a table, well, I want to click on that column and sort it. I want to interact with that report. I want to click on that field and filter, maybe resize columns to adapt to my page. So interactivity became more and more a need to cover with our products. So once we start talking about interactivity, you actually interact with something, and you interact with a web app. So this is how the idea of creating a web-based kind of service or product came around. Of course, for those few of you who know what JasperSoft does, you know we do have a product called Jasper Server. I'm not going to talk about that one. It's there. We have customers for that. But what we wanted to create was some sort of a microservice. We wanted, if we had this library that could be used by any Java application for offering reporting functionality, we wanted a service or a usable microservice that could be used in any other application, regardless of the technology it uses or it's deployed on, to leverage our reporting engine. So we wanted this microservice to do only one thing and do it very well. We wanted to do only reporting. So this is how JasperReports IO came into being. It only does reporting, nothing else. It doesn't have security. It knows nothing about user or stuff. It just exposes the REST API. It doesn't have a scheduler to schedule reports. Nothing. Just endpoints to trigger report execution, like I want to execute this report, here's my parameters, run it for me. It runs them asynchronously, meaning if it takes like 2 minutes for a large report to run, I can check the status. Hey, I launched this. How is it going? Is it done? Can I see it? Give me the first page. So all these endpoints make up this comprehensive REST API that can be used from any application to generate reports. And let's see a few details about this capability. So it's a simple and powerful REST API. Basically, it exposes all the functionality that the reporting engine has. It allows generating and using interactive visualizations, like you get this output in HTML format, and then there are hooks in our output where you could click on something and generate another request that will probably make a modification on the report template, run it again, so you see back the result has changed. So this is how you interact with reports. All this is encapsulated into a JavaScript API that helps you embed these visualizations into your own web pages, into your own web application. Now, we all know that software development shifted from server-side, where I enjoyed it, to client-side. So there's a lot of JavaScript nowadays, and we are offering this JavaScript API because a lot of web development happens nowadays in JavaScript. The service has a small footprint. We're going to see in a demo. Checking time. All right. Basically, if I were to start this service, we have various distributions of it. The smallest one, the simplest one, comes with the Jetty web server. If I start that one, it starts in like 4 seconds. It's up. So very, very small footprint there. We have a distribution that is designed for cluster deployment with Docker images. We're going to see a diagram of that. And what I wanted to say is that having experience with our bigger Jasper Server product at JasperSoft, when we created this one, we designed it with scalability in mind, because our, let's say, monolithic server has, it can be deployed in clusters, but has a bigger footprint, and it's not that suited for cluster deployment. Okay, how to use JasperReports IO. I said it's only about reporting and data visualization. So it doesn't have security, it has nothing. You cannot expose that directly. So the way it's supposed to be used is behind your firewall. It's just as from a web application, just as you use a database to store your data for your application, you generate your reports with our JasperReports service, which is deployed inside your local network, and you don't expose it outside. The way we use JasperReports IO REST API is by proxying it. So the parent application has the exact endpoints as JasperReports IO. Execute this report, give me the status, give me the PDF, what's going on. All these endpoints are in your application and they are proxied because it's the parent application that offers the security infrastructure. It's there where you log in, you know, obtain tokens and all that stuff. And behind the scenes, you ask for reports and then display them. All right. Let's see some of this stuff. So I'm going to switch to my web browser here. All right. So this is, well, JasperReports IO is a REST API service. It doesn't have a UI of its own. So what we see on screen here is just a basic HTML static application that helps me show some of the reports. But it's not JasperReports IO. JasperReports IO is the application that delivers this document. So when I click on this thumbnail there, this is JasperReports IO. It's a report produced by JasperReports IO by making REST APIs. And this report viewer that looks like Adobe Reader is part of our JavaScript API that helps you embed this stuff into your own websites. Okay, so it's a 37-page document, and I can export to PDF quickly. And it looks exactly the same. So this is our perfect pixelness, let's say. It looks exactly the same in Excel and all our formats. The resolution is not very good, so I apologize for that. All right, how is this thing embedded? Well, we have a reference documentation for our JavaScript API, and just to take a quick look at a JS Fiddle, if you're familiar with this environment for testing JavaScript. So basically, in your web page, you just load a script from our GRIO web server and define a container, like a div tag here, where you want your report to appear. And then with a little touch of JavaScript, with a GRIO object, you just say, hey, I want to run this report found at this URL in the URI in the repository, and the result I want it to display in that div based on the div ID. And this is how this report on the bottom right side has appeared. It was embedded into this page by this JavaScript here. Of course, the JavaScript API is complex. It offers possibility to display reports page by page, or to pass parameters, to show bookmarks and all various features that our documents have. So I would not insist on that. All right. Let's now see a little website that makes use of all this stuff that I just showed. So I have a WordPress website. I mean, it's just a regular website. It could be your typical BI blog or whatever. And on some of the pages, I embed reports generated by an instance of JasperReports IO that runs on the same machine, but it's not actually, or it should not actually be visible from outside. That's what I just said before, the way we deploy. But if I go to this page here, I have, it's the same report displayed 3 times because I wanted to show that the style of charts changes from one instance to another, because there's a parameter saying the chart theme is iCandy 60s or AJN or default. So we can pass parameters to the reports, and they react to these parameters when passed like that. So they're embedded into the page in a div. There's a little arrow in the corner of each of the reports, and if I click on it, it opens the report viewer in an overlay. Again, it looks a bit like Acrobat Reader, but it's actually HTML. And I can navigate from one page to another, export to PDF, and all the good stuff. Now, let's see a bit about interactivity here. So this orders report, we've seen it before. When embedded here, it looks like a photo, although it's HTML. It looks like a photo because I click on it, nothing happens. But interactivity here is disabled on purpose here, because when I click on columns and try to do stuff, there'll be dialogues appearing, and we don't want to interfere. We don't know how this would look in the website, so we just said, well, let's disable it for this website. But if I do want to interact with this report, I click again on that little arrow, and then interactivity is available here because I have more space. So I could click on this column and sort the records on that. Or I could even conditionally format this report. So for example, the detail rows, if this column customer name contains, let's say, Rancho, contains Rancho. I want the background to be orange. So I solicited a change in the report template, and the report was rerun, and the change applied. All right, I could resize columns and all there are various types of interactivity available here. All right. What else? There's also a leaflet report. You know, this is a case where we use what we call a custom component. This is a leaflet map, and it's interactive. I mean, it has built into interactivity. We didn't need to write anything about that. It just comes with leaflet. There are markers there which we draw from by retrieving data from a data source, and then when we click on them, they react. They could react in various ways. Everything is configurable here, and you design this stuff using our visual designer normally. All right. I said that JasperReports IO, the engine that runs these reports behind the scenes, doesn't have any security. It just does reports. Give me the parameters, tell me which report you want to run, because it looks for them into a repository, and then it gives back HTML, PDF, whatever I ask for. However, here I'm in WordPress, and WordPress does have security. So the way security is implemented here is that I had to write a proxy, just like I said before. I wrote a proxy to basically expose the REST API through WordPress itself. And in that proxy, every time I call JasperReports IO behind the scenes, I inject user information. Like, I know who's logged in here, and I will run a report that displays this information. So there are so-called built-in parameters injected into every report execution and can be used in report expressions. Like, I could have a query that filters orders by username. So this guy, Teodor here, which is logged right now in this website, can see only Teodor's orders because the username can be used as a filter into the report query. How do I know this is the true? I mean, and this information cannot be hijacked because it's injected behind the scenes. This traffic between WordPress and JasperReports IO is not seen in the browser. It happens on the server, just like I connect to a database from PHP. It's not visible from here, so it cannot be hijacked. If I log out and I run that report again, I wouldn't be logged in, so no user information anymore. All right, here we have just an example that with a simple click, I can go straight to PDF. I could go straight to Excel, go straight to Word. So you could have links to just download the file, never looked at it before, just straight to PDF. And you can imagine this JasperReports IO service being used by cron jobs or scheduler technologies from third parties You write jobs in which you make REST calls, and you can generate thousands of reports and put them in a folder, overnight. So it can be integrated in any other product. And actually, there's business process management tools that, in those processes that they design, one of the steps is generate these reports with JasperReports IO in a loop. So it can be integrated in this sort of tools. All right. Okay. Any question at this point? Oh, okay. Now, I think it's a good time to go back to the slides and go at scale. So what we have here, I'm not sure if the text is very readable, but it's a diagram of our JasperReports IO cluster. When we say cluster, we usually say Kubernetes, but there can be other cluster technologies. But what we've done is that since we designed it with scalability in mind from ground up, we knew when it comes to scalability, certain features or certain aspects of the product need to scale differently. Like when we generate these documents, there are two major steps involved. One is filling the report with data. So we take the template, we get the parameters, and we probably connect to the data source, so we retrieve the data, and we mix this to produce what we call a proprietary document format. The so-called Jasper print is our document format. It's like PDF, but like objects in Java. And it's from that intermediate document format that we export to PDF and all the others. So this process of mixing the template with the data, we call it report filling, and is the most CPU consuming and memory consuming process of the whole thing. So it is this one that needs to scale independently of the others, because exporting to PDF, it's cheaper. I mean, with PDF, we just stream some bytes. We don't consume memory. It's not that CPU intensive because we don't measure fonts or things like that. So in this activity of running and viewing reports, there's filling and export. So we want filling to scale while exporting could consume less, because it's about cost. It's about how much I pay when I deploy at Amazon. So it's important to scale when you need and where you need. So what we are seeing here is the whole ecosystem. Like we have requests coming from the client, which can be a browser or actually a parent application, that it's making REST calls to what we call JasperReports IO REST pods. We don't need too many of those. Maybe one and one for failover, because these are not doing much. What they're doing, they take my request and put it in a queue. We have a queue of report executions where they can pile up, because we also have a throttle about how much can we execute at any given moment. For example, we can control whether 10 or 100 or 1,000 report execution can run concurrently. If we lower this threshold, then report executions stay more in the queue. They don't fail. They just stay there longer until they're picked up by the so-called GRIO manager. This is another pod. This one doesn't scale. We only need one GRIO manager. If this one dies, doesn't matter. It's recreated and it picks from where it left. So we only need one of those. What we need a lot is these guys, JasperReports IO. I mean, with all the virtualization and all that stuff, still consume a lot of memory because we measure text, and measuring text involves Java, AWT procedures that are CPU consuming, and then memory is consumed if the reports are big. So this is where most of the stuff happens. So, when a report execution occurs, from the execution queue, a report is generated and placed in the stack of generated reports. Now, with these guys there, they sit there, but you don't see them, because in order to see them, you need to export them to HTML, PDF, or whatever you want to display. So that's done by another specialized pod, which is the export pod. These guys are not that CPU intensive as the reporting ones, so they scale independently. We probably need fewer of those. Two probably are too few, but fewer than reporting. And when these guys export a report, they place the result, which can be PDF, HTML, or byte array, or Excel, or whatever the format is, into a list of generated exports where they're delivered by the REST pods. They pick it from that stack. So this whole rectangle here contains the queues and the list of requests, generated report, export reports. This is a shared replicated cache that we implement using Redis. So all these workers around this big cache here, they can die and are recreated, and nothing is lost, basically. I mean, we lose something if during the 2 minutes it takes for a big report to generate, if that worker dies. I mean, chances for it to die are small, but still, if it dies, then that report execution is lost. However, if any of the pod is dying after he has finished his work, it doesn't matter, because what he did will be picked up by any other pod that it's recreated, and it doesn't, I mean, they all keep their information into this shared and replicated cache. That's why we need Redis for, not as much for its caching functionality, but for its cache replicating cache replication functionality. We need these objects that are in memory to be available to all virtual machines, to all workers, and they read it from Redis. When we go at Amazon, Redis can actually be replaced by Elasticache. We've done tests with that, and it works very well. So how far were we able to push this stuff? We made tests at Amazon with our clusters, and we were able to generate 100,000 report executions during 1 hour, and it cost us under $5 for the whole hour. So it gives you a sense of cost effectiveness. 100,000 reports in an hour for less than $5. Yeah. That's all I can say about this diagram. So let's now see how are we using this reporting technology in the context of big data. Drivers. So we connect to any major big data engine through JDBC drivers. And having this capability of putting the queries inside the reports, we only need a connection to that big data server, and we execute that query and get the result. Again, we need a flat kind of tabular result set that we iterate through and process, and it works great. But in many cases, what we want to do with big data is to push down queries, to let the server, the data server, deal with all the complexity of processing and preparing the data. And many of our customers actually wrote their own data REST services in which they give us back massage data, filtered out, processed, aggregated, whatever. And they give it to us in the form of JSON or XML. And processing or using JSON or XML data, it's easy for us. XML, we we process using XPath queries, again, for making the nodes, transform nodes into tabular kind of data. And for JSON, we came up with a query language, I would say not of our own, but has certain special aspects. We call it JSON-QL, just to flatten out a structure of JSON nodes and process it. So yeah, that's a very common use case for us, not to connect to big data directly, but customers have their own layers, and they provide data to us already processed. There's one case where we had to implement our own connector. It was for MongoDB. MongoDB has a MongoDB so-called native driver in Java. So we wrapped it and we read tabular data from these objects that they return. And in reports, end users end up writing MongoDB query language queries. So we have a few customers with us. Unfortunately, I'm not able to share real customer cases with you. I'm just explaining what are the major scenarios here. When it comes to big data technology, we pretty much have customers using everything. Redshift is very popular with our customers. Also, BigQuery is. And lately, Snowflake, we've seen a peak in popularity for Snowflake. Now, what kind of customers use this? Well, we have some big customer in automotive industry, and very many customers in finance. Well, when it comes to finance and banks, there's a lot of need for pixel perfectness and the kind of documents that we generate. I mean, even in Romania, if you have online banking and you could check the PDFs of some of these major banks and see what are generated with, you might see JasperReports there, like transaction logs and all those PDFs that are available in the online banking application. And of course, in back office, they have others that use our technology. In case of companies for wealth management, they do portfolios. Energy, oil, gas, I mean, every company of this sort needs to print invoices. We have a company in Northern Europe that generates millions of invoices every month for the customers. And there's a lot of PDF and documents and complex documents like that in education, where they print student records and transcripts and all that stuff. I think we're close to the end, so I thank you and wait for questions.
Thank you very much.
Hello, that's both impressive and amazing what you've managed to accomplish. I was wondering about the architecture you've shown us. What are some like bottlenecks and what in terms of processing rates, in terms of data? You didn't mention how big the reports are, like how much data can it process and what are the bottlenecks in that architecture?
Bottlenecks related to data. Frankly, if you ever we try to persuade them to, split it into smaller chunks, because it's beneficial for various reasons. And chances are that they could do that easily because that big report is probably grouped by something, grouped by country or something. So if you could split it into a few chunks, that's good practice, we think. So I don't know. I cannot think of any bottleneck right now. If there's a problem in this area, then there's a bug we need to solve. So yeah, I don't know. It could be that the memory problem comes from the data itself. I'll give you an example. Let's say you feed a report with Excel data. Until a few weeks ago, we had the Excel data source using POI, a Java Apache library. And when we load an Excel file with POI, a 13 megabytes Excel expands to 3 gigabytes in memory. So you can end up with memory due to POI. And that's why we implemented recently, actually in the latest release, a new Excel data source using a library called FastExcel, which doesn't load everything from that Excel file, only loads the data. So 13 megabytes Excel only expand to 50 megabytes in memory, which is almost nothing. So again, it could be that the memory out of memory comes from maybe the data or other technologies that are involved in that report generating process.
Got it. Great job. Thank you.
Thank you.
Thank you, Teodor. Do we have another question, maybe? If not,
right.
We are right on time. So
Thank you.
thank you very much, Teodor, for your lovely
Thank you.
presentation. And see you soon.
Yeah,
Maybe.
thank you.